Let me give you an example of a feature. For example, if I am working on a face recognition application, then the input data set will consist of a number of individuals, right? So I will be using many facial features in that case. So I will have a number of images of different individuals, and those images will mainly be the frontal face portion of the individuals. And in that case, for this specific applications, my features will be the facial features. For example, I will be looking into the nose, eyes, ears, and the shape of these things. So these will be my target features in this application, and my machine learning pipeline will be extracting these kinds of features in a face recognition application. Similarly, if I have some weather prediction data set, so in that case I will be looking into the humidity, I will be looking into the wind, the speed of wind, and these kind of things, and all these things will be acting as the features for my application. So the thing is that the type or nature of the feature can be changed with on the basis of your data set and your application, but those features should be distinctive, and it is good that there should be enough distinguishing characteristics in the feature, and those features should be quantifiable and measurable. So, for example, if we want to classify an email into a normal email or into a spam email, then in that case, what will be my features be? So, number of words that have been changed like this, right? And I can also look into the language of the email, right? So for example, if I denote English with 0 and Spanish with 1, and maybe if there is some other language, I am denoting it with some other character. And I can also look into the number of emojis that are being used in the uh, emails. So if I have this kind of text in my email messages, then I will be performing some kind of feature engineering. I will be representing some words with some integers, or I can use some other kind of encoding. But all these things will be acting as features for my spam classification application. Now, extract more information from existing data, not adding in new data, right? So, it is important to look during feature engineering phase that we are not interested in adding some new data into the existing data, but it's good to extract more features or more information from the existing data which we have already, right? And the target is to make it more useful, right? We want it to be more informative as much as possible, and it should be with good features. Most algorithms can learn faster, right? So as I told you earlier, that the performance of an algorithm is highly dependent on the features, right? So the most informative, discriminative, and quantifiable features we have, then we can expect that our algorithm will not only learn faster, but it will also provide good accuracy, sensitivity rates as well. So the feature extraction phase, it plays a very major and vital role in the performance of the overall, not only on the performance of algorithm, but on the overall pipeline. It can be an art, requires thought and knowledge of the data, right? So extracting features and then performing engineering on those features can be a very trickier part as well, right? Especially if you have some complex data, or the nature of the data is a bit complicated, then in that case it is necessary that you will have some prior knowledge of the data, right? And it requires some thinking process. You will have to go some background knowledge, and then you will be able to understand that data, and then there will be a higher possibility that you will be extracting more relevant features and will be performing feature engineering in a much better way. So there can be two steps which can be involved in it. It's variable transformations, for example, dates into weekdays, and then maybe we can be performing normalization on that, and then feature creation, for example, n-grams of text if word is capitalized to detect names, right? So you can look for this kind of information, because normally, or in emails or in some other text, normally names are capitalized. So you will have to see that which information can is most distinguishing information, and if that is can be used for features or not. Okay, so now we have seen some definition and abstract level information of different types of machine learning algorithms. We have now have a basic understanding of supervised machine learning algorithms, unsupervised learning algorithms, and reinforcement learning algorithms. We now know that what is the basic difference between each category, and what on what situations we will be using which type of algorithm, right? So now let's have a look that which algorithms lies in which category, or how many algorithms we have in a specific category. So if I talk about the supervised learning, then there are a number of algorithms which lie under supervised learning domain. So let me recall it that in supervised learning domain, I will use an algorithm which is under supervised learning domain only for that data set that for which I have the labeled data, right? So we can use some linear classifiers in supervised learning domain. We can also use naive Bayes algorithm, which is a probability based algorithm. We will have a full lecture on this. And we have SVMs, the support vector machines. They are supervised algorithms. Although by using some modifications, we can also use SVM through some semi-supervised learning as well. But the classical support vector machine is trained under supervised learning domain, and we will have a full separate lecture on this as well. Then we have decision trees, and there are various types of decision trees, and they also perform under supervised learning domain. And we also have random forest, so we will having detailed lectures on the decision trees as well. And then we have KNN, right, which is K nearest neighbors. K nearest neighbors is basically used to group different samples of data, and that also comes under supervised learning domain. And then we have a whole new field of study which is all based on neural networks, right? So we will have a couple of detailed lectures on neural networks, and you will see that neural networks are a very powerful algorithm or technique which helps us in a number of tasks, right? So the shallow neural network is a classic example of a supervised learning domain, and we basically have a bunch of data with labels, and we train our neural network which contains a number of layers and parameters, and through supervised learning we train our neural network. And on the basis of this neural network, we have a lot number of other deep learning algorithms which are a variation of these neural networks.